In this lecture, we solve the differential equation x square y plus y to the power 4 whole dx plus 2x cube plus 4xy cube whole dy equal to 0. We have to solve the given differential equation x, just a minute. Now we have to solve the given differential equation x square y plus y to the power 4 whole dx plus 2x cube plus 4xy cube whole dy equal to 0. Now, how to solve this differential equation? So now, since this differential equation is not variable separable form, it is also not the reducible to variable separable form, it is not homogeneous, and also now we can check that it is exact differential equation or not. So if we check it again, it will not be the exact differential equation because del m, let me try to del m del y. What is del m del y? Del m del y, which is equal to x square plus 4y cube, and del n del x is equal to, what is del n del x? It is 6x square plus 4y cube. So clearly these both are not equal, so it is not a exact differential equation. So now it may be reducible to exact differential equation. So for that purpose, what we will do, we have to check that we have to actually we have to find out the integrating factor when we want to reduce any differential equation to its exact differential equation. So is it possible to find out the integrating factor of this using we cannot use the rule number 1, we cannot use the rule number 2, we can use the rule number 3 and 4, right? But here, since there are exactly two terms or exactly four terms, out of that, the two terms are associated with dx and two terms are associated with dy, then when such and the power of x and y are higher and only algebraic terms are present, so such type of differential equation may be arise in the rule number 5. So now here we will try to apply the rule number 5. Definitely this equation can be solved using the rule number 5. So in case of rule number 5, if you want to apply, we have to just put x to the power h and y to the power k be the integrating factor of equation number 1. Since x to the power h and y to the power k is integrating factor of this equation, so it means that if you multiply this x to the power h, y to the power k to the given equation 1, it may be converted into the form of exact differential equation. So let us multiply 1 by integrating factor x to the power h, y to the power k. We have x to the power h, y to the power k whole times of x square y plus y to the power 4 whole dx plus x to the power h y to the power k whole 2x cube plus 4xy cube whole dx equal to 0. Let us again try to simplify. X to the power h into x to the power 2 is x to the power h plus 2. Y to the power k into y to the power 1 is y to the power k plus 1. The first part is over. Similarly, x to the power h into x to the power 0 is x to the power h. Y to the power k into y to the power 4 is y to the power k plus 4 whole dx plus similarly x to the power h into x to the power 3, which is equal to 2x h to the power x to the power h plus 3 and y to the power k plus x to the power h plus 1 means 4 times of x to the power h plus 1 and y to the power k plus 3 whole dy. So this is the differential equation and which is multiplied with its own integrating factor. So clearly the equation number 2 is exact differential equation. Now we know that equation 2 is an exact differential equation, but we know that the necessary and sufficient condition that m dx plus n dy equal to 0 be exact is del m del y minus del n, del m del y which is equal to del n del x. So let us try to find out the value of del m del y and del n del x. Since m equal to x to the power h plus 2, y to the power k plus 2, k plus 4, sorry, and m equal to 2 times of x to the power h plus 3, y to the power k plus 4 times of x to the power h plus 1, y to the power k plus 1. So del m del y, which is equal to del n del x, gives us what is the partial derivative of m with respect to y. So this is constant, and the derivative of y to the power k plus 1 is k plus 1, y to the power k into x to the power h plus 1, plus here derivative of y to the power k plus 4 is k plus 4, y to the power k plus 3, and x to the power h. Similarly, this is the partial derivative of m with respect to y. Similarly, we can find out the partial derivative of n with respect to x. This is not m, this is n. So partial derivative of this means 2 times of h plus 3 into x to the power h plus 2, y to the power k plus 2 4 times of h plus 1 into x to the power h into y to the power k plus 3. Now let us again comparing the coefficients of equal powers of variables we get. Just look here. Here x to the power h plus 2 y to the power k, x to the power h plus 2 y to the power k. Here also x to the power h plus 2 y to the power k. So what is the coefficient of both the term? It is k plus 1, which is equal to 2 times of h plus 3. Similarly, x to the power h y to the power k plus 3, x to the power h y to the power k plus 3. So if we see again this term, so their coefficient is k plus 4, which is equal to 4 times of h plus 1. So now these are the two equations in h and k, and if we simplify these two equations, we are able to get the value of h and k. So which gives us k plus 1, which is equal to 2h plus 6, and k plus 4 is equal to 4h plus 4. So this 4 and 4 will cancel, and k is equal to 2h minus k, 2h, this is transpose this side minus k, and this transpose this side, plus 1 minus 6 is minus 5, and k is equal to 4h. So if you put k is equal to 4h over here, solving above equations, we have, let what will happen? K is equal to 4h. So 2h minus 4h is equal to minus 5. So minus 2h is equal to minus 5, which gives us h is equal to 5 by 2. And if h is equal to 5 by 2, then what is the value of k? It is 5 by 2 into 4, which is 10. The value of k is 10. The value of h is equal to 5 by 2. So 2h minus 4h, which is equal to minus 5. H gives us 5 by 2, and k equal to 4 into 5 by 2, which is equal to 10. Therefore, x to the power h into y to the power k, which gives us x to the power 5 by 2, y to the power 10 is the integrating factor of equation number 1. Putting h is equal to 5 by 2 and k equal to 10 in equation number 2, we have x, this is equation number 2, x to the power h plus 1, y to the power k plus 1 plus x to the power h into y to the power k plus 4 whole multiply by dx plus 2 x to the power h plus 3, y to the power k plus 4 times of x to the power h plus 1, y to the power k plus 3 whole dy, which is equal to 0. Now let us put the value of h is equal to 5 by 2 and k is equal to 10. So we have 9, this is what? 5 by 2 plus 2 is 9 by 2. This is 10 plus 1 is 11. H is equal to 5 by 2. Y to the power 10 plus 4 is 14. Whole dx plus 2x. H is equal to, what is the value of h? It is 5 by 2. So 5 by 2 plus 3 is 11 by 2 and y to the power 10 plus h is equal to 5 by 2 plus, so 5 by 2 plus 1, which is 7 by 2, and y to the power k is equal to 10, so 10 plus 3 is equal to 13, whole dx equal to 0. Here m is equal to x to the power 9 by 2, y to the power 11 plus x to the power 5 by 2, y to the power 14, and n is equal to 2 x to the power 11 by 2, y to the power 10 plus 4 times of x to the power 7 by 2, y to the power 13. Now if we find out the del m del y is what? It is 11 y to the power 10 x to the power 9 by 2 plus 14 x to the power 9 by 2 y to the power 13 del n del x. Why? Because if you find out the del n del x with respect to x, then it is 11, 2 into 11, 11 by 2, so 2 will cancel. 11 x to the power uh, 9 by 2, 11 by 2 minus 1, and y to the power only 10. Okay, so because it is free from, if y is constant, y to the power 10 is constant. Similarly, here y to the power 13 is constant. Partial derivative of x to the power 7 by 2 is x to the power 9 by 2 upon, x to the 7 by 2, x to the power 5 by 2. So 4 into 7 by 2, x to the power 7 by 2 minus 1. So this is this 1, 2. So 14, sorry, this is plus 1. 14 7 by 2, this, sorry, it is 9 by 2. This is 9 by 2. 9 by 2, x to the power 9 by 2 minus 1, right? So this is 14 into 9 by 2 multiplied by x to the power 7 by 2. Okay, we have to differentiate it. So x to the power 7 by 2. Just a minute, once more. Partial, this is what? It is 11, 2 into 11 by 2, x to the power 9 by 2 into y to the power 10 plus 4 into 7 by 2, 7 by 2, I think this is not correct. It is not 9 by 2, it is 5 by 2, sorry. It's 5 by 2 into 7 by 2 into x, 5 by 2. 5 by 2. So now this 2 will cancel. 11 x to the power 9 by 2, y to the power 10, and 14 x to the power 5 by 2 into y to the power 13. So now both del m del y and del n del x are equal. So hence the given equation number 3 is exact differential equation. So once, since it is exact differential equation, so we are able to get the general solution, which is given by the general solution of equation number 3, x to the power 9 by 2, y to the power 11 plus x to the power 5 by 2, y to the power 14 whole dx plus 2 x to the power 11 by 2, y to the power 10 plus 4 times of x to the power 7 by 2, y to the power 13 with respect to dy equal to 0 is given by integration of y m dx when y is constant plus integration of terms of n not containing x, that is into d whole dy equal to integrating constant. So the value of m is equal to x to the power 9 by 2 plus y to the power 11 plus x to the power 5 by 2 y to the power 14 whole dx, and there is no term which is free from x in the n part, so it is 0, which is equal to integrating constant. So let us try to integrate it. Y to the power 11 we can take outside. So integration of 9 to the power 9 by 2 x to the power 9 by 2 is, and similarly here y to the 14 x to the power, this is 5 by 2. So to the 11 x to the power 11 by 2 upon 11 by 2 plus y to the 14 x to the power 7 by 2 upon 7 by 2 equal to c. So now this is 2 upon 11 y to the power 11 x to the power 11 by 2 plus 2 upon 11 7 y to the power 14 plus x to the power 7 by 2, which is equal to c. So this is multiplying whole by 77 by 2. We get 7y to the power 11 into x to the power 11 by 2 plus this is, we have to multiply by 77 by 2. So 7 into this 2 will cancel, only 11 y to the power 14 into x to the power 7 by 2, which is equal to 77 by 2c, which is equal to c1, which gives us the integrating constant. So 7x to the power 11 by 2 y to the power 11 plus 11x to the power 7 by 2 into y to the power 14 is equal to c1, where c1 is equal to 77c upon 2 is the desired general solution of the given differential equation. Thank you.